24 hours. That is how long it took Typhoon Bavi to go from a distant tropical storm to a projected Category 5 equivalent monster with a typhoon-watch on American soil. 200,000 United States citizens in Guam and the Mariana Islands are now in its path, facing forecast winds near 172 miles per hour and seas of 45 feet, with the worst arriving between Sunday and Monday. This is what you need to know: how strong Bavi can get, which islands take the core, and why the most important number in this forecast is still a guess. Yesterday morning, the National Weather Service Forecast Office in Tian, Guam issued a typhoon watch for 4 American islands: Guam, Rota, Tinian, and Saipan. The headline on the local statement was written in capital letters, and it did not hedge: Typhoon Bavi intensifying rapidly east of Guam. A separate tropical storm watch went up for the northern islands of Alamagan, Pagan, and Agrihan at the same time. Taken together, those watches cover the entire inhabited Mariana Islands chain, United States soil in the western Pacific, home to roughly 200,000 American citizens and nationals. The numbers attached to that watch are the reason this story leads today. Forecasters are warning of winds near 150 knots over the Marianas coastal waters, roughly 172 miles per hour, with gusts to 180 knots, which works out to about 207 miles per hour. Seas are projected to build as high as 45 feet. On the Saffir-Simpson scale used for Atlantic hurricanes, Category 5 begins at 157 miles per hour. Bavi's projected peak is not near that line. It is well beyond it. The timing is just as important as the intensity. As of the watch issued yesterday, typhoon conditions, sustained winds of 64 knots or greater, are possible across the Marianas within the next 24 to 48 hours. That means the window for preparation is today, not this week, today. Emergency guidance calls for preparations to be complete by tonight, with the worst conditions expected tomorrow into Monday. A typhoon watch on U.S. territory with a projected Category 5 equivalent peak would be a major story in any week. What makes this one different is how fast it happened, and how much genuine uncertainty still hangs over the single most important number in the forecast. Both of those threads run through everything that follows, and it starts with the speed. 2 days ago, Bavi barely qualified as a story. The storm, designated 09W by the Joint Typhoon Warning Center, was a strengthening tropical system roughly 960 miles east of Guam, about 1,545 kilometers out, moving west-northwest near 15 miles per hour. Its sustained winds were around 60 miles per hour, up from 45 the period before. Forecasters flagged it as a system that would intensify. There were no watches, no warnings, and no headlines. Within roughly 24 hours, all of that changed. The forecast peak climbed to Category 5 equivalent. The typhoon watch went up on American soil, and the language in the official products shifted from routine tracking to the phrase that matters most in tropical meteorology: intensifying rapidly. Rapid intensification has a formal definition: an increase of about 30 knots, or 35 miles per hour, in a storm's maximum sustained winds within 24 hours. It is the single hardest behavior in tropical weather to forecast, and it is the most dangerous because it compresses the timeline that everything else depends on. Evacuation decisions, shelter openings, flight schedules, port closures, all of it is built on the assumption that a storm's strength changes gradually enough for warnings to keep pace. A rapidly intensifying storm breaks that assumption. The storm that existed when you went to bed is not the storm that exists when you wake up. That is precisely what happened here. The residents of Guam and the northern Marianas went to sleep with a distant tropical storm on the map and woke up to a typhoon watch with a projected peak among the strongest storms on Earth. And the escalation may not be finished, because the water Bavi is crossing right now as some of the most dangerous storm fuel on the planet. We will get to that. First, the numbers themselves deserve a closer look, because they are worse than they sound. 150 knots of sustained wind is not an abstraction. At 172 miles per hour, wind stops behaving the way most people picture wind. Well-built wood frame homes lose roofs and walls. Concrete structures survive, but their windows, doors, and utilities often do not. Power poles snap rather than lean. Trees are not stripped of leaves. They are stripped of bark or removed entirely. The gust figure matters even more. At 207 miles per hour, a gust can turn loose debris into projectiles capable of penetrating reinforced structures. This is the kind of wind that rewrites the building code after it happens. The ocean numbers are their own hazard. Seas of 45 feet in the surrounding waters will make the approach unsurvivable for any vessel that has not already reached port, and the surf and surge that reach the island's coastlines will arrive well before the strongest winds do. On top of the wind and water, Model guidance points to storm total rainfall on the order of 250 millimeters, roughly 10 to as much as 18 inches in the heaviest zones, enough to trigger flash flooding and mudslides on islands with steep volcanic terrain. The Japan Meteorological Agency, which tracks storms in this basin using 10-minute averaged winds instead of the 1-minute standard American agencies use, classified Bavi as a very strong typhoon with a central pressure near 925 hectopascals as of 2 days ago. Different agencies, different measuring conventions. Same conclusion. This is a top-tier storm, and it was still strengthening in every forecast cycle available as of yesterday. Every one of those numbers, though, comes with an asterisk that most coverage of this storm will not mention. The wind figures are estimates, careful, skilled, professionally produced estimates, but estimates. Nobody has measured this storm directly, and nobody is going to before it arrives. That asterisk is one of the two things that will decide how this weekend goes for 200,000 Americans. The other is the track. The forecast models do not agree on where Bavi's core goes, and on islands this small, that disagreement is everything. The American Global Model, the GFS, has favored a track toward Tinian and Saipan, the two main islands of the Commonwealth of the Northern Mariana Islands. The European model, the ECMWF, has leaned farther south, taking the core toward Rota and Guam before carrying the storm onward into the Philippine Sea. Longer-range guidance splits again after the Marianas, pointing variously toward Luzon, Taiwan, or Japan next week. The Joint Typhoon Warning Center's forecast, as of the most recent complete cycle, calls for Bavi to peak as a super typhoon near 155 miles per hour tomorrow, with the center passing just south of Tinian around 8 o'clock Monday morning, local island time. If that forecast verifies, Bavi would be a candidate for the strongest July typhoon ever to pass directly through the Marianas, a projection brushing up against the record books in a basin that has seen the most powerful storms ever measured on this planet. Here is why the track spread matters so much. Guam is about 30 miles long. Tinian and Saipan are smaller still. A typhoon's most destructive winds live in the eye wall, the ring of violent thunderstorms surrounding the calm center, and that ring may only be 20 or 30 miles across. Shift the track 15 miles north or south, a rounding error at the distances these models work with. And a given island moves from the eye wall's direct path to its outer edge or the reverse. The difference between a direct core passage and a near miss on an island this size is not a matter of degree. It is the difference between a catastrophe measured in years of recovery and a severe storm measured in weeks of cleanup. That is the coldest arithmetic in this entire forecast. Which island takes the core is currently inside the margin of error. The steering currents that will settle the question, the strength and position of the subtropical ridge of high pressure to the storm's north, will do so over the next 24 to 36 hours, which is why every forecast update between now and Sunday matters. And while the track decides who takes the hit, the ocean underneath Bavi is deciding how hard that hit will be. The Philippine Sea in early July is arguably the most favorable environment for explosive storm intensification anywhere on Earth. Right now, it is delivering on that reputation. Sea surface temperatures along Bavi's path are running 29 to 31 degrees Celsius, bathwater warm, and well above the roughly 26.5-degree threshold that tropical systems need just to sustain themselves. The surface number is only half the story. What makes this basin exceptional is heat content. The warm water here extends far down into the water column, hundreds of feet in places. That matters because an intensifying typhoon churns the ocean beneath it. Over most of the world's oceans, that churning drags up cooler water from below, and the storm effectively chokes on its own wake. Over water this warm and this thick, the mixing brings up more warm water, and the storm keeps its fuel line wide open no matter how violently it stirs the sea. Add the atmosphere, and the picture completes itself. Vertical wind shear, the change in wind speed and direction with height that can tilt a storm's core and tear it apart, is low. The outflow aloft, the high-altitude exhaust that vents air away from the storm's top, is strong. Warm sea, thick heat reservoir, low shear, healthy exhaust. Those are the four ingredients of rapid intensification, and Bavi has all four at once. There is one internal break that could still slow the climb, and regular viewers of this channel have seen it before. In our coverage of Typhoon Jangmi in late May, we walked through the eye wall replacement cycle, the process where an outer ring of thunderstorms forms around the original eye wall, contracts, and strangles it. A replacement cycle typically pauses intensification and trades peak wind for a broader wind field, spreading somewhat weaker winds across a wider area. Whether Bavi starts that cycle before Monday is one of the two open questions that will decide what the Marianas actually experience. Forecasters cannot schedule it, they can only watch for it, and even the watching in this basin is harder than it should be. But before we get to the blind spot, there is one more piece of context that raises the ceiling on this storm. The benchmark for the Western Pacific, the benchmark for the entire planet, was set in the same basin in October of 1979. Typhoon Tip bottomed out at a central pressure of 870 hectopascals, the lowest ever measured in a tropical cyclone, with winds estimated near 190 miles per hour and a wind field over 2,200 kilometers across. Tip remains the most intense storm ever recorded. It is the storm every other storm in this basin gets measured against. Bavi has been flirting with that company in at least some of the modeling. Outlier runs of the European model have produced central pressures for Bavi in the range of 871 to 883 hectopascals, numbers within shouting distance of the all-time record. An outlier run is exactly that. An outlier, and responsible forecasting, does not treat the most extreme member of a model ensemble as the prediction. But the fact that credible, modern guidance can even generate numbers in that range for this storm tells you what the environment underneath it is capable of supporting. The background state loads the dice a little further. The Pacific is in a neutral but warming pattern right now. The index that tracks El Niño stands at plus 0.48 degrees, 1/100th of a degree below the formal El Niño threshold, after climbing steadily for 6 seasons. Viewers who saw our El Niño coverage in June know that trajectory. More important than any climate index for a single storm, though, is the simple baseline. The background ocean is warmer than its historical norm, and a warmer ocean raises the theoretical ceiling on how strong any storm can get. To be clear and honest about the science, no single storm can be attributed to that warmer baseline, and Bavi is not evidence of anything by itself. But the ceiling is higher than it used to be, and Bavi is climbing toward it over the warmest water this basin has to offer, aimed at American soil. Which brings us to the most uncomfortable part of this entire story. The number everyone is relying on might be wrong, and there is currently no way to check it. In the Atlantic, when a hurricane threatens the United States, aircraft fly into it. The hurricane hunters, Air Force Reserve and NOAA crews, punch through the eye wall multiple times a day, dropping instruments that measure the storm's winds and pressure directly from inside. Those flights are the gold standard of intensity measurement, and coastal forecasts are built on them. In the Western Pacific, there are no routine reconnaissance flights. None. The aircraft-based program in this basin ended decades ago. Every intensity number you have heard in this report, the 150 knots, the gusts to 207 miles per hour, the super typhoon peak forecast, comes from satellites, interpreted primarily through something called the Dvorak technique, a pattern recognition method developed in the 1970s that maps the shape and temperature structure of a storm's cloud tops to an estimated intensity. Forecasters supplement it with microwave imagery that sees through the cloud shield, and with scatterometer passes that estimate surface winds. It is skilled, disciplined work. It is also, at the extreme end of the scale, genuinely uncertain. The technique is weakest exactly where Bavi is headed, the top of the scale, where the difference between 140 and 160 knots is hard to read from orbit and enormously consequential on the ground. That means a storm estimated at 150 knots could be meaningfully stronger or weaker than the number on the advisory, and the truth may not resolve until Bavi is close enough to the island's radar and surface stations to be measured directly. By then, the preparation window is closed. 200,000 Americans are, in effect, preparing for a best estimate. Predictably, that gap has fed a familiar pair of claims online. One says storms like Bavi are engineered or steered by secret facilities. The arithmetic kills that one immediately. A mature typhoon releases power on the order of 100 trillion to a quadrillion watts continuously, many times the output of every power plant on Earth combined, and its motion follows the well-observed steering flow around the subtropical ridge, which is modeled openly and verified daily. The other claim says officials are hiding how strong Bavi really is. That one inverts the truth. The uncertainty is not hidden. It is published. Forecasters are openly flagging the observation gap as a limitation of the system. A cover-up does not announce itself in the forecast discussion. The honest story is less comforting than the conspiracy. Nobody is concealing the storm's true strength because nobody knows it to the exact knot. That is the actual state of the art over the Western Pacific. And this weekend, the actual state of the art is what stands between an estimate and 200,000 people. The population in Bavi's path is specific and countable. Guam is home to roughly 153,000 people, along with one of the most significant American military concentrations in the Pacific. The Commonwealth of the Northern Mariana Islands, Saipan, Tinian, and Rota, adds about 47,000 more. Together, that is approximately 200,000 United States citizens and nationals inside the watch area, most of the mainland's time zones away, and, if history is a guide, mostly outside the mainland's news cycle. These islands are not starting from zero. The Marianas were hit hard by Typhoon Sinlaku in April, and parts of the territory are still rebuilding from that storm. Roofs still under repair, infrastructure still stressed, reserves already drawn down. A second major typhoon arriving inside the same year does not simply add damage, it multiplies it, landing on structures already weakened and communities already stretched. The calendar makes it harder still. Preparation Day is today, the 4th of July. The peak of the readiness window has landed on the biggest holiday weekend of the American summer, which means shutters are going up and water is being stored on a day when much of the island population would otherwise be at barbecues and beaches. Emergency guidance calls for preparations to be complete by tonight. The islands have hard-won experience here. This is the most typhoon-tested population under the American flag, with building stocks and public routines shaped by decades of storms. That experience is real, and it will save lives. But experience does not change what 170-mile-per-hour wind does to a roof, and it does not widen a preparation window that rapid intensification has already compressed. What happens next comes down to the storm's final track and final strength. So here is what to watch as both of those lock in. The first signal is the upgrade. A typhoon watch means typhoon conditions are possible within about 48 hours. A typhoon warning means they are expected within about 24. If and when the watch converts to a warning for Guam or the Northern Marianas, likely within the next day if the forecast holds, that is the operational signal that the islands are committed to taking this storm, and the last preparation hours are running out. The second signal is the track trend. Watch whether successive forecast cycles nudge the center line north toward Tinian and Saipan, or south toward Rota and Guam. On islands 30 miles long, every 15-mile shift redraws the map of who takes the eye wall. The steering ridge will settle that question over roughly the next day and a half. The third signal is the intensity estimate itself. New satellite-based numbers arrive every 6 hours. If the estimates keep climbing toward the 155-mile-per-hour peak forecast, Bavi stays on record-threatening footing, a candidate for the strongest July typhoon ever to pass directly through the Marianas. If an eye wall replacement cycle begins, expect the peak numbers to level off while the wind field broadens, which trades the worst-case core for a wider area of damaging winds. Neither outcome is good news. They are different shapes of the same dangerous storm. Beyond the weekend, Bavi does not disappear. The guidance carries it onward into the Philippine Sea, with Luzon, Taiwan, and Japan all inside the longer-range possibilities for next week, meaning that Marianas may be only the first landfall story this storm writes. The bottom line is direct. A rapidly intensifying typhoon with a projected Category 5 equivalent peak is bearing down on 200,000 Americans. The destructive core will pass within a forecast error of 4 inhabited islands between tomorrow and Monday, and the true strength of the storm will only be confirmed when it arrives. Preparations on the islands need to be finished tonight. We will be tracking the watches, the warnings, and every forecast cycle as Bavi closes in, and as the Western Pacific reminds everyone why it builds the strongest storms on Earth.